introduction to my second theory, the theory of Earth's electric field. My theory is based on thermoelectric effect, which is the direct conversion of temperature differences to electric voltage and vice versa. My theory is also based on the second laws of thermodynamics. Our entire universe is obeying the second law of thermodynamics, like stars or sun, from hot to cold. So is our planet Earth. I postulated due to the flow of mobile electrons from outer core toward the crust, there is an electric field and the separation of charges. Due to the unique characteristic of Earth having iron and nickel in inner and outer core and negative Thomson effects, the electric current is recycled back to the Earth center through the magnetosphere. In order to replicate the Thomson effect, I did an experiment I will demonstrate later. Earth is a perfect conductor, not like metals and flow of charges. I compared the Earth to the battery's electrolyte, and conduction is by the movement of ions called proton conductors or positive hydrogen ions. Earth, including oceans, lakes, can have conduction with both hydrogen ions and electrons. According to my experiment, an analog multimeter set on resistance or continuity check, when I stick the positive and negative probes into the soil, shows perfect electrical conduction. I also theorized the transformers theory due to the Earth's inner core's iron and nickel content. The generated electric current around the core is concentrated, also enhanced. The Earth electric field, when current flows toward the crust, I also did some experiment which proves the Earth's electromagnetic induction on ferromagnetic, paramagnetic, and diamagnetics, which I will demonstrate them. Finally, I concluded that the Earth's generated electric current polarizes everything regardless of their compositions. Thank you. This is another experiment for thermal conductivity, and I have copper, aluminum, and iron. If I heat at this point copper, I'm going to be feeling the heat at the end. So is the aluminum. So in other words, this copper and aluminum, they have positive Thomson effect. In other words, when they're heated here, the mobile electrons are flowing away from the heat toward the cold section. So away from the heat toward the cold section. But in iron is exactly the opposite. When I heat this section over here, the flow of electrons are toward the heat, and this is called negative Thomson effect. So you can see the electrons are moving not away from the heat, but toward the heat. It is due to the thermal conductivity by mobile electrons. This is exactly what happened inside the Earth. Due to the intense heat, the generated energy, the electrons flow toward the crust and create a current, and consequently the separation of charges. This is another experiment. This is the iron metal, so I just wanted to demonstrate Thomson negative effect. So I had to heat this up to 1000 Fahrenheit, but you can see this metal or the iron strip is graduated up to the 20 inches, but it's exactly like I showed the other experiment. The mobile electrons, when it's heated like this, is flowing toward the heat, not away from the heat. But on the copper, I'll show you later, it's exactly the opposite. When I heat this part in the copper, the mobile electrons are moving away from this. And what I did, I bought this infrared sensor. It can heat the room temperature. Well, of course I did this. It's 79 Fahrenheit. But when this was glowing almost, when I measured this with infrared was showing exactly 1000 Fahrenheit. I'll show you. I have to heat this up. It might take a few minutes because unfortunately I'm a little bit low in gas. It seems that my gas tank is a little bit low because it should take less than a minute. This gets above 1000 Fahrenheit. When I measure this, you can tell it went to almost to 600, 700. But see, when I feel this here, it's amazing. Nothing happened. You can tell maybe the second, third, and fourth, you can tell like 300. This one, let me see how much this one shows. 125. But it's exactly the opposite thing happened in the copper. If I heat this up, the copper is going to be hot all the way to 20 inches graduation. The reason why, the mobile electrons are moving from the heat, away from the heat toward the cold section. In order to replicate the Thomson positive and negative effect and relate them to the Earth's outer core, and the diffusion of moving electrons toward the base of the material, I did an experiment. And in fact, this is a copper you can tell, and then exactly like iron, I graduated to 20 inches, but the copper has a positive Thomson effect. When it's heated like this, the mobile electrons are moving away from the heat. It's exactly opposite like iron. And then, like I said, again with this infrared, I'm going to measure this. Let me see how much it shows. Well, it's showing 429. And like I said, unfortunately, my gas is a little bit low. But when you feel here, it's extremely hot. The reason why, this exactly has the Thomson, positive Thomson effect. And the mobile electrons or the conduction by electrons are from heat, away from the heat toward the cold end. As I explained in my theories, Earth is a perfect conductor. See, this is like a multimeter, and if I connect this to metal like this, you can tell it's showing the perfect conduction. The same thing happened for Earth. If I connect this to Earth, it's going to show perfect conduction. You can tell showing the perfect conduction, see? It's exactly like if I'm connecting to a metal. As I explained in my theories, Earth is a perfect conductor, and then I compare the Earth with a huge electrolyte or like a battery, and you can tell when it's set on a resistance, if I stick this, you can tell it's showing the perfect conduction. And then I also did another experiment to show that Earth can act like an electrolyte, and then I have a copper and zinc, and copper has 1.9 in a Pauling scale or electronegativity, and zinc has 1.6, and in fact when I stick this in a soil, or it can be like a battery's electrolyte, is exactly the same. I can get almost 1 volt DC on this. The reason why, the electrons are flowing from the highest electronegativity, which is copper 1.9, to 1.6 zinc. I'll show you. When I set this on the DC voltage, you can tell that's 1 volt DC voltage, and when I connect this, it's showing the DC voltage, see? And I know, of course, the copper is the positive, and the other one is the negative. See, you can tell. You can tell? It's almost 0.8 volts DC. And then I've changed the polarity, the flow of electron will be reversed. You can tell. See? It's going backward here. And in fact, in Earth, we have this proton conductor or the hydrogen conductors, and it's conducting electricity perfectly. And you can tell here the electronegativity shows it's exactly like a battery. I also theorized that Earth's core is acting like a transformer core, and I call it transformer theory. And in fact, the generated electricity or the current is around the core or in the outer core. And something amazing happened here. It's almost like 2,600 kilometers, the solid iron and nickel, and this is acting exactly like a transformer core. And not only it enhances the all around, it enhances the line of forces or the charges, but also it enhances and multiply them millions of times, because anytime you have a ferromagnetic like a transformer like this, if there is no iron core, there will be induction, but very low. But when we have this iron or ferromagnetic core, it enhances thousands of times. But imagine how big the Earth's core is. This is another example. This is more powerful transformer. But you can tell, without the core, there won't be any enhancement whatsoever. And Earth, it does the same thing, exactly the same thing. With this experiment, I wanted to demonstrate that the Earth's electric field can polarize everything. But how could I do that? So I took some ferromagnetics like this, a strap, and even igneous rocks like this. I picked them up from a backyard. So when I get this close to the compass, you can tell, even though it's never been magnetized, but they do have charges, you can tell. See, this part is south. When I just move along like this, it's going to change. See? This is going north, and then south all the way. And I, in fact, noticed something strange. The same thing happened in electromagnet like this. Well, of course, this is a long solenoid, like 18 inches. If I connect this to 12 volt DC, it's exactly the same. Same thing happened. Well, of course, I'm energizing that. It's going north and all the way south. So I can show you also the igneous rock like this. These are ferromagnetic rocks, but not 100% because I could not tell. See, there's some ceramic inside, some probably silicon inside. But see, when I get this close to the, see, this part is the south. See, both of them are activated. And when I reverse this is north on this side. So this is a little bit stronger. They call them lodestone, or they call them igneous rock. You see, this part is south. When I reverse this, it's going to be north. And in fact, when I found this, I connected to 12 volt DC, and as a matter of fact, the conduction is almost perfect. I would say 95% conduction. Well, of course, there's some impurities inside I cannot tell. And then I did something also special. I thought if I measure this and then put north-south all the way, when I cut this in half and the Earth's electric field will induce, so immediately they should assume the new polarity. So my guess was right. See, this is exactly the same strap like this. So when I connect it in half, you see they assume the new polarity. I'll show you. See here, it shows north. But as soon as I cut this, is almost like a magnet, so technically I will have two magnets even though they've never been energized, but the Earth's electric field will induce voltage on this, so it'll be south on one side, north on the other side. Let me cut this. So now, technically this 18 inches is 2 see south right there, and comes to north here, see? Here's north. And before it wasn't north, see? Before it was southwest, but now the charges are traveling all the way to the end. So that's why we have two different. And in fact, I work in Golden, Colorado, and there are some railroad abandoned, and I got my compass, both of them, and I must have checked almost a mile, exactly was the same pattern. I had north, south, and I just checked a mile, and there was no doubt in my mind that the Earth's electric field is polarizing everything. Well, of course, we cannot see it, but if I had a better compass, not like these ones, I could measure 100%, but of course, these are ordinary magnets. I have another experiment I demonstrate in a minute. This is another experiment to demonstrate the Earth's electric field